Wow, we're back already. I just said peace. Oh, so cool. Thanks for being here. So on our next lesson, we were using a calculator to graph stuff. Hey, it actually did work, I think. Oh, maybe not. Let me close that. Okay, so we were just learning how to use graphing software and the calculator, cool, to graph some things. And so perfect. And so now we're going to be doing, let's see, 7.4. I lost it. Where'd you go? Aha, there you are. Okay, so now we're going to be learning something new, and that's using the normal distribution, right, to calculate percentages of probability. So what I mean by that is, let's say someone walked in the room. Could we guess what percentage chance that they would be a certain height? Well, if the average height is like 5'8" with a standard deviation of 3, right? Like this. Let's go ahead and scroll down. So this is how it works basically. Here's the idea behind it. 68, 95, 99.7. So 68% of people are going to be between -1 and +1, with our average x bar of 0 in the middle. And so those are standardized numbers. Let's say we change those and we say like, oh, well, the average height is let's say 5'8". And so we'll say 5'8". Well, 5 foot is 60, so 68 inches. And let's say there's standard deviation of like, I don't know, 3. So if we have a standard deviation of 3, we're going to add 3. So 68, 69, 70, 71 inches. And so 71 inches, how tall would that be? 5'11". And so let's say that 5'11" is 1 standard deviation above the mean. And then we'll take 68, we'll minus 3. And that's 66. No, 65. And so that would be like 5'5". And so what we can say then, right, according to a rule that we're going to teach you, is that 68, oh, that's a height. Don't confuse it. I better use a different color because that's going to confuse you. Why did I say 68? I should have said 5'7". That's okay. Okay, so let's say that, so cool. So this is a whole different thing. New thing here, guys. New, not the height. This is a percentage thing. Okay, so it turns out, according to our rule, 68, 95, 99.7. So that's the empirical rule. And so we would say 68%. So that means that 68% chance that someone, the next person that walks in the room, is going to be between 5'5" and 5'11". If our average height was 68 and our standard deviation equals 3. Standard deviation is just like the spread, how far the data is spread out, and so that would be So you could have a standard deviation of like 3 or 4 or 5 or 1 or 2 or a decimal. Likely there's like a decimal. And so when we did our calculator with those scores and stuff before, we actually had one of our stats. We actually had a standard deviation of just 1.9, and so the average is 3. And so 1, 2, 3 standard deviations above the mean, and 1, 2, a -1, -2, -3 standard deviations. And a negative standard deviation just means below the average or above the average. Wow, I'm giving you a lot of information. I hope you can hang in there. Okay, so we have a calculator to calculate this percentage for us. And maybe you don't want the percentage from 5'5" to 5'11". Maybe you want just this percentage, 5'8", which is the average, right? 5'8" to 5'11". Well, that's easy. We could just cut 68% in half, and that would be like 34%. And that is true. That is true. But what if you want to go even further and say, I want to know a probability someone, the next person walking the room is not 5'8", but 5'9" to 5'11". Whoa, Nooble. Now you're getting tricky on us. Sorry, 5'11". And so to do that, we would use our calculator. We would use our calculator. Specifically, we would use second bars, the second distribution. Remember when you did the graph? I forgot to tell you that y equals sometimes has stuff here that mess up your, like y equals 8, for example, or y equals 1. you want to clear those before you do your graph, because that might mess up your graph. And so especially if you use Zoom 9 and it might mess it up. So just make sure that you go to y equals, clear your graph, then go to second stat plot and start working on your graph there, histogram. Okay, beautiful. So second quick, we're doing a normal distribution centers. So second distribution. We're going to use something called normal CDF for this next part of the homework assignment. So question 4, 5, 6, all the way down. So we're going to be using normal CDF, okay? Use normal CDF. Or if you don't like normal CDF, you could use statisticshelper.com, normal distribution calculator. And how I found that was just like typing in normal distribution and statistics helper and .com. And so that you can plug in lower bound, upper bound, mean, standard deviation, same as the calculator. Okay, so we have let's just jump right in there to the homework problems. We have a mean of 24 and a standard deviation of 4 is what they give us. And then your sample size n, 500, is big enough that we can do this. What percentage of scores on the ACTs last year were between 20 and 28? Were you one of those people that got an ACT score between 20 and 28? And so what you would do is you go to your calculator or your website, you decide, and you would put in the mean of 24 and the standard deviation of 4. So sorry, you got to do select normal CDF now. So again, you go to vars. No, you go to second. You go to second vars, second distribution, and then normal CDF option 2. Okay, so mine is doing it in a fancy way, which yours isn't going to do, but that's okay. Type in 20, 28, 24, 4. Let me show you what yours probably looks like. So yours probably looks like this, right? Yours probably looks like normal CDF without anything plugged in yet. Okay, so again, how it works is lower bound, upper bound, mean, standard deviation. Should we write that down for you? Write that in your notes somewhere. So here's the syntax for normal CDF, right? So it goes comma, it's asking for first the lower bound. In this case, it's going to be 20. Then it's going to ask for the upper bound next, right? And then comma. Your comma is above the 7, so use above the 7 to type in your comma. So upper bound, these are our bounds, right? Our lower bound and upper bounds. Lower bound, upper bound. And so our upper bound is going to be 28. So far we're going to go 20, comma, 28, comma, and then what comes next is the mean. That comes next. This is what you type in, your syntax. And then last but not least is your standard deviation, which is this guy right here, standard deviation. So you're going to go 20, 28, comma, and then 24, and then comma the standard deviation, which the standard deviation they gave us was 4. So let's go ahead and type that into our calculator and see what percentage it gives us. Okay? Watch this video again if I went too fast. Okay, here we go. So we're going to go 20, comma, 28, comma, with a mean of 24, and a standard deviation of 4. Look at that. We get 0. What the heck happened? Oh, second enter brings up the last thing you did. And I forgot to do the lower bound. What was our lower bound? Oh, our lower bound was not 28. It was 20. Yeah, there's nothing between 28 and 28. It's 0. Okay, there you go. Well, look at that. 68, 68, 95, 99.7. Empirical rule. So 68%. And so we're going to go ahead and type in 68%. We're going to click that as our selection there. And then we're going to go ahead and try it again. But this time we're going to do between 16 and 28. It says how many percentage scores. So you're going to do the same thing, and but you're going to type in 16 to 28 basically. So you just push second enter, brings up the last thing you did. I'm just going to change that 20 to a 16. Bada bing, bada bing, bada boom. 81.8% is what that is, or 82%. Or 81.5% is closest. I should probably fix that. I think they meant to put 8, 5. Sorry, I got this from another teacher. Okay, so that's closest, I guess. That's going to be that's lame, huh? So I guess this will be 81.9%. Really? But 81.5% is the closest. Anyways. Okay, cool. So then if you want to do a lower bound or an upper bound, right, what percentage scores are less than 12, then you go second enter, brings up the last thing you did. Or if you want to remember, you go second distribution, you go to option 2. There we go, second bars. And then we're going to do 12. So we're going from 12. Oh, what percentage scores are less than 12? So we're going to choose like a big negative number. Like, I don't know, negative 999 is our lower boundary. And then our upper boundary will be 12. And then with a mean of 24 and a standard deviation of 4. So again, negative 999, comma 12, comma 24. Cool. So that's 0.001, which is basically 0. What percentage scores are less than 12? I don't even see a 0 percentage. Man, this is lame. I need to fix this assignment. Sorry about that. Oh yeah, that's a 0.015%. That could be right. Should be 0.013, but whatever. Yeah, so 0.15% of a percent, right? If that's 1%, then this is 1/3%. Yeah. I should change these numbers to be more exact because I like that better, but stay with me, stay with me. Approximately how many students scored higher than 28? So you do the same thing. You do the same thing, but you're going to change, instead of, so higher than 28, you would change your lower bound to 28, and you would change your upper bound to 999, right? 28 to a really big number, and that would be 15.8%, which would not be 16% is what that gets closest to. I can see that, okay. Cool, so give that a try. Ooh, wait a sec. Approximately how many students scored higher? Yeah. What percent? Oh, how many students? Well, what's 16% of 500 is the question. What's 16% of 500? Ooh, 80. So you actually might need to change that to 80. You see how they tricked us there? So you have to take your percentage and times it by 500 basically, is what we did there. I'm going to make another video because my other class is coming in and this was pretty long anyways. So peace out and talk to you soon. Bye for now. Peace.